Hi all, I'm Eetu. I'm from Finland actually, from Aalto University, but currently I'm doing a 3-month visiting scholarship at Stanford University at the Humanities plus Design Laboratory, working on how linked data can aid in humanities scholarly research. But today I'm talking about what to do with linked data, or what's linked data good for, and that's a sort of theme of research that I've been engaged in for more than 10 years. I'm a computer scientist, and I've been sort of looking at what are the actual new functionalities that linked data might enable, and what sort of user interfaces and data integration tasks need to be done to actually attain those new possibilities. I'm hoping you all load this URL, which is the URL for this presentation, because there are some links later in it that I hope you follow. But it's a pretty simple URL, so I think you'll remember it if I already go to the next slide. So what I'm going to talk about is what's linked data good for? What are the sort of, there was a good question about the numismatic data. You could have that in an SQL database. What's better about having it as linked data? So that's exactly what I'm about, is discovering what's linked data particularly good for that you couldn't do with databases. And another end user perspective that I was asked to talk about here is what actual tools are available for you as end users to interact with linked data. But there's a sort of other side of the coin is the publisher perspective. So if you have multiple data sets, and you want to know which of these to publish as linked data, which would bring people added benefit, then I can maybe answer some of that. What needs to be done to the data? What are the actual important things to do to data to make it a part of the linked open data cloud ecosystem? And additionally, sort of what sort of browsing and searching and other functionalities you might want to provide for your data. So, but moving on to the beef, what's linked data good for? If you have linked data, what can you do with it? And the context that I'll demonstrate this is the Cultural Sampo portal, which was published already 6 years ago in 2008 in Finland. And the reason it's still a good example is that it's one of the only places where you get very many different types of material from very many different organizations together, and it's not only rich material, but it's richly interlinked, which is the key point here. We've done a lot of trouble, gone through a lot of trouble to take these collections and actually form a network out of them. And that's really different from, for example, Europeana, which does contain a lot of material from different collections, but it's still, the material they have doesn't cross collections really well. It doesn't really actually form a semantic network. So, but this one does. And let's look at what you can do with it. So, the first thing you can do, is to just browse all of this linked data. And the reason this is interesting is that you're now able to move in the context of all this culture. It's rich culture, it's richly interconnected, it forms a rich network, and now you're finally able to browse this. So this is the Finnish national epic of Kalevala. It's an epic poem, and we got, for example, the plot structure as structured data here, and we have keywords for individual sections of the poem, so we can find other sections of the poem that deal with similar themes. And because it's actually collected from folk poetry in Finland, and we have the original folk poetry collection database, we can actually also go to the source poems that this was created from. But we can also get from fiction to artworks depicting the characters or actually the particular scenes in the poem from the National Gallery. And we can get other paintings from the same painter. We can get other works of art, sculptures or whatever, dealing with the same themes. And we can actually also get exhibitions that are in museums that deal with these same themes, and so on and so forth. We can move to the information about the painter and get a look at their sort of their contact network of other people they know, social network, the sort of paintings they did, and so on and so forth. We can then move on to the biography for this painter that's in the Finnish National Biography Center. Sorry. And on and on. So we can endlessly wander around this network of culture without regard to which institution holds the material. The important thing is that we're all times maintaining sort of semantic connection to where we are. So this is a place in Finland, and for that we can get videos dealing with it, biographies of people that did something in this place, aerial photographs depicting the place, museum items manufactured or used in this place, current events that are happening there, exhibitions and so on, museums that are located there. Very rich material, again without regard to the type or where it's originally from. So that's browsing, and I think this sort of in parentheses conceptualization is really important. That's what you're really doing here, is you're navigating the contexts of culture in Finland. All right. So that was Culture Sampo. Then there's also, I'll just very quickly show this. This is an offshoot of Culture Sampo called Book Sampo, which the Finnish public libraries really liked what we did in Culture Sampo, and they wanted to do this in the domain of fiction literature in Finland. And they actually did research that showed that people who are wanting to interact with fiction literature need the added context. They need to know stuff about the writers and in addition to the content of the work in order when they're sort of looking for something to read. So this has very similar sort of functionalities that you can browse the main characters and find other works that have these same main characters. And there's also some intelligent recommendation that is able to give you also explanations on why it's recommending a particular other book for you to read. So that's browsing. Then there's another thing and contextual browsing being the key. Another thing that linked data does really well is relationship discovery. We already today saw this relationship finder interface, and I'll show it again a bit later in this presentation, so I'll not go right now into the details of it. But that's one thing that it does. It discovers relationships. Then finally, you can do search, But it's not the search that's important here or interesting. It's the fact that the search, again, is sort of a form of, is able to contextualize stuff. So I'm searching for Lemminkäinen, which is a major character in the Finnish national epic Kalevala, and I can get all the poems that speak of him and actually know what he does in those poems. It's brought here. I get all the works of art and also a description of how Lemminkäinen relates to that work of art, and so on and so forth, until I get to this weird video of a Finnish guru who was actually a tour guide, and he said that he's found a temple of Lemminkäinen in his backyard in Sipoo and got the Finnish mining company Lemminkäinen to donate a lot of money to him to do digs in his own backyard in Sipoo. And this is a video article from the Finnish public broadcaster discussing this whole affair. So we get the position of Lemminkäinen in all of Finnish culture. You can do more analysis, and the keyword here also being interactive. So here's there's an explore view in Culture Sampo, and just looking at everything that relates to churches and putting them on map, you get a distribution of churches, maybe accurate, maybe not. Or you can look at anything that relates to beards, and you can see that in the late 19th century, Finnish beard fashion changed from these big bushy beards to sort of small whiskers. And then very many artists who were born in Europe came to the United States to die. So this is plotting birthplace and death place. So on a map. And here I'm looking at all items that were manufactured in Japan and used in Finland to see changes in imports in the 20th century. So it's a two-dimensional graph. Here's time and here's the type of item. And you see that until the 1970s, people imported mostly toys and plastic stuff from Japan to Finland, but then it starts to get more and more high-tech with cameras and lenses and such. So moving away from Culture Sampo, this is more recent work. This is sort of a biography viewer where biography information and publication information is gathered from multiple spatial endpoints into a viewer that allows you to sort of see a person's lifetime as events, and they're linked to sometimes places and also places in addition to times. So you will see sort of the geographic layout of that person's life in space and time, aggregating from multiple sources. So, for example, books by this writer come from the Book Sample project, and the biographies come from the Finnish National Biographic Database, and so on. And then this is another project of World War I data, and here's our sort of atrocities committed by German units in Belgium, placed on a map and on a timeline, so you see what happens during the war, and I actually later have sort of an example of this. Other questions, I know the most popular colors of people's underwear in Finland. But the first three are pretty obvious. I don't know what's up with yellow. And then the Book Sample data tells me that international novels started getting longer in their page counts when Tom Clancy started writing, but we are in Finland very slow to catch up, so our novels started to get longer only in this millennium. And I know if I want to get a government literary grant or literary award in Finland, I have to write about women in the countryside during the Second World War, because based on sort of analysis of Booksampo data combined with literary grant data, I found that novels dealing with those themes get way more grants and awards than other novels. So that's sort of what you can do. You can browse, you can discover relationships, you can analyze across dimensions. So the multidimensionality is really key here. And you can sort of, yeah. And that also sort of answers the question of what makes for good linked data. Good linked data is some data that's a part of a wider context, can be made part of a wider context. But the hard part is manifesting, linking to that context. So actually Europeana is very bad currently, the data. It's just pushed there, and it consists mostly of literals, and they are not linked really, the collections, to each other. They do not form a rich network. And that's the hard part, and the hard part is specifically sort of linking the attribute values to common vocabularies. From my experience, people always obsess about the schemas. So we have to define a schema that's common to all people, and then the problem is solved. But that doesn't solve the problem at all, because the schemas do not make the network, the values do. But luckily, we nowadays do have quite many good value vocabularies for common things to use also. So people, we have the Getty Union List of Artist Names, we have BIAF, which unfortunately doesn't contain all the information that's in the marked version of BIAF. There's a lot more structured information that's not in the RDF version of it. So it contains only the names, the name clusters of people, but that's still very good for linking. Then we have, for places, geonames is the most popular, Getty thesaurus of geographic names, probably. And then for ancient places, there's the Pleiades project. And then for general, we have DBpedia, the Getty Arts and Architecture Thesaurus, Library of Congress subject headings, and for works of fine art, their content is often described using icon class. But there's really isn't anything to deal with sort of events, even though very many of these models actually try to link together these collections through events. For example, CDOC CRM is really event-centric, but it doesn't really help anyone integrate the collections if they're all events, if you can find which events are the same. But CDOC CRM is a very good schema to use, and actually the Europeana data model, all the good parts of it come from CDOC CRM. I mean, the Europeana data model, what it adds to CDOC CRM is actually more sort of technical and provenance handling, which is of course important. Europeana wants to know where this comes from, but it's not actually, it doesn't add anything to the domain modeling. And the CDOC CRM is what sort of models the people, places, and events, and objects, and their relationships between each other. And CDOC CRM documentation is additionally much better than EDM documentation, so you should read that. Yeah, there's the big frame effort for books that's ongoing. There's the W3C organization ontology that's quite good for encoding information about people and the organizations they belong to. Relationship does that for people, so relationships between people. Then there's the friend of a friend, schema.org, and so on and so forth. So So I think the takeaway from this is that you should use these common schemas because they're good and someone has thought them out. But when you get a new property that doesn't fit in these schemas, you don't have to form a working group that does 3 years of work to develop a new standards. Just put something out there because it's not that important. This is much more important.
I can't let that go. Tell me about your lack of events schema.
Not lack of event schema, but lack of a controlled vocabulary containing events. So, well, we'll see it a bit later, but we, for example, have now done reference dataset containing events of the First World War, so battles and so forth. So that's what I mean. I mean sort of these value vocabularies that you need to share in order to link the data together. Okay.
Isn't that what Wikipedia is for?
Hmm?
Isn't that what Wikipedia is for?
Yeah, Wikipedia is great, and as a sort of so Wikipedia and DBpedia. DBpedia is a really great core for all of this stuff, for events, people, places, and general concepts, as long as they're notable enough to be included. And sort of, for some domains, the problem is also that Wikipedia is not authoritative enough. So I've been dealing with this World War I context, and humanities scholars there say that, yeah, Wikipedia is fine, but you cannot cite it in my class because no one knows what's going on there. And actually, while people have done research that shows that Wikipedia is really accurate in sciences, other research shows that actually in the humanities the sort of accuracy isn't that good. So they have some reason to sort of doubt Wikipedia.
I'm sorry, can I just, if you'll let me drill a little bit on this event. So do you want, if not Wikipedia, some other kind of reference point for every event that ever happened?
Yeah.
It's all right for every event?
Yeah.
Great. That's a really nice project.
Yeah. Yeah, it is.
So me your money on that together. We'll get it. Yeah.
And just to clarify, you're talking now about URIs for instances rather than URIs for predicates. So you want
Yes. So
here is a subject versus the predicate DC term subject.
Yeah.
Clearly there are many data models for events.
Yeah, I definitely should have been more explicit here because in various communities there is a great amount of confusion, or they're talking about different things using different terms. So what is a schema for one and what is an ontology to another varies from community to community. So here I'm talking about things that if you have a museum item and you have the place of manufacture and it's manufactured in San Jose, then you get the URI for San Jose from one of these. So the values of properties should come from a common vocabulary. And the property place of use in my terminology is a part of the scheme. Okay, so that's the rant on the publisher's viewpoint, and then completely switching gears and to a different topic to end user tools. So what tools you can have right now to deal with linked data that has been published by someone else. And this is a link, and you should now open that because it has some examples in it. First, when you're encountering a new data set, you probably don't know what it contains. For that, I've developed a tool called Eetu that's able to visualize the contents of datasets. This is the Europeana dataset. Once it loads, I don't know why it's taking so long, but in the meantime I'll show another tool that I wasn't planning to show, but because then you were complaining that you haven't had time to document the schema, so I pointed our vocab@at tool at your SparkUL endpoint, and it generated a schema documentation for it. And it also states that, for example, you're using these classes and these properties from your own schema. And you can also see that these classes have these properties and so on and so forth. And it also highlights the fact that your vocabulary isn't dereferenceable, so it's not described in the namespace that it's stated to be in. So that this vocab@at tool creates textual descriptions of dataset schema. The Eetu tool creates visual descriptions of datasets. So the Europeana dataset contains close to 1 billion triples, and 78 of them are URIs, and 22% are literals. So it actually looks pretty good. Resources mean connected network, yes, but actually when you're looking at the property graph, you see that all of these URI references come from precisely this sort of provenance metadata, and actually all the core metadata, the topics, what this is about, are literal references. And they're not very good at that, so other problems in the dataset are, for example, that apparently most of Europeana is in Romanian. But that's not actually the fact. The fact is that they're not very good at language tagging their literals even. So all of these 2 million topics can be in whatever language in Europe, and they may mean the same thing, but they're not linked, and we can't use an external dictionary to link them even, because we don't know which language they are in from the literal description. But so this Eetu tool is here, and you can use it. These are just already generated descriptions of available data sources, but you can generate and visualize a description for any SparkUL endpoint. I didn't do it for the numismatic endpoint because they're quite heavy queries, some of them, and I didn't want to crash it. But otherwise I'd shown also a visual representation of that. But if you have sort of your own SparkUL endpoint, you can get a visual description of what it contains. So that's first. Then, if you have a SparkUL endpoint, one of the things was things that were sort of useful about linked data was just browsing. So we have again a browser tool for that that can just be pointed again into any SparkUL endpoint, and it'll generate an interface such as this. So in all the classes that are in the dataset, this is now the World War I dataset, it contains a lot of events, and then you can go look at that event and just browse the data. And you can see all of the other events that are related to the Western theme. These are actually, I think, yeah, these are events mined from Wikipedia by John, and which I imported in here. But there are a lot of other data sources also providing events for this data set. So that's one thing. If you have a data set, you can get a browser on top of that. I won't show you exactly how, because that would take a bit too long, but you can ask me. Because I want to move on. Just quickly highlight YASGUI, which is a user interface for doing SPARQL queries. If you sort of are doing SPARQL queries, this is really nice because it allows for auto-completion of properties and so on, and it also does syntax highlighting and highlighting of errors. So if I put something here, it immediately says that this is not valid SPARQL. And you can get sort of the results nicely formatted, but you can also then download them as CSVs to use in whatever tool you want. So that's for sort of just doing SPARQL queries plain. And then one look at Relationship Finder. So so this document that I linked you previously has links to the sort of SPARQL endpoints that you can try in these tools, and also links to ready sort of created queries for these various tools. And I'm showing Relationship Finder first. So based on our World War I data, what was Germany up in the Belgian province of Namur? And it finds that they destroyed buildings there, and that created financial burdens and civilian hardship, and resulted in, or related to, the Belgian rejection of German authority, and so on and so forth. They apparently took human shields there also at some point. And that was a violation of the Hague Conventions. This is another data set that I developed at Stanford now that contains material on 18th century European letters that people wrote to each other, and also lifetimes of people and their travels in Italy. And we can see which sort of people connect London and Milan. So some people were, some people visited Milan, others wrote letters to people who were born in Milan, others actually wrote letters to people who were in Milan at that time, and so on and so forth. So you can find relationship with Relationship Finder, and now you have sort of a couple of endpoints to try this on, and you have example queries. I actually really wanted to show how to configure these. How am I for time?
Good.
All right.
25 minutes.
All right, excellent. So I actually have quite a lot of time, so I will really show you how to look at this Relationship Finder. So if you want to point Relationship Finder into your own SPARQL endpoint, you'll want to go to the settings and then create a new configuration. And the only thing that you have to give it is the SPARQL endpoint URL. And then additionally, you probably want to ignore some properties. So it doesn't, for example, say that Milan and London are both places. That's very interesting, a link between them. And there's also a list of auto-completion URIs. So what that does is when you're typing here, that just states that which properties to follow to give these results. And with that, giving a couple of properties that define which are the labels in your data set and which are the not interesting properties, and the SparkQL endpoint, you can take this tool and use it and run. Okay, that was Relationship Finder. And then, because YAS GUI is open source and allows you to extend it, I've extended it so that in addition to getting sort of these table responses, you can directly get the results of your SparkQL queries as Google graphs. And I have an example here. This is data from the French National Library on publications combined with their authority data. And this query and visualization, on this axis are the number of total books published, and on this axis are the number of books books from people who are philosophers that were published. And this was used by researchers at Stanford to sort of discover which places publish disproportionately much philosophy in the French language. So Amsterdam, Geneva, and sort of and a lot of them don't have this sun's location, don't have a location, so the disproportionate number of Enlightenment publications were published in some place that they will not say. And what was interesting was that they actually had the hypothesis that London would be one of these places, but it doesn't go pretty far here. So that was sort of an unexpected result of this. I have too many tabs open, can't anymore find where I was. Let's put it again. So yeah, you can. That was a Google graph, and you can plug stuff from your SparkQL query into these Google visualizations. But I also configured the Visu interface to allow you to export stuff in KML, which is the key wall markup language that Google Earth uses. And through that, I linked to Europeana 4D, which is able to use KML data from external sources. Let's see if this actually works. And visualize them.
Getting all the data from here? Is that
Well,
Google Earth plugin for Europeana?
What I mean?
Yeah, what is this tool right here? This is the Europeana 4D thing that you just referred to?
Yeah, this Europeana 4D is a project by some guys in Germany who did it. I don't know when, because their homepage doesn't say it, but it's at least 3 or 4 years old. Seems to be sort of abandoned, and no one responds to any emails, but it has a nice interface, which I want to show you if it would allow me. So basically what it does is that you get a nice timeline and a nice map, and you can sort of move the timeline here and get the points that were active at that time highlighted on the map. And it has has maps and boundaries of different eras. So for example, in this example you can also select points by where they are in a particular era. So here our dataset has been partitioned to East and West Germany by the borders of that time. So you can compare right-wing crimes between those areas that were a part of East Germany to those that were a part of West Germany. No, not loading. Well, that would have been a fun example. That was, I think, well, you can check it later if it will work again. So that was sort of some events of the First World War on a map, particularly French and Belgium. So you get a sort of little idea where the action was or was not, because they're all on the sort of Western Front line at various years. So, but you can also use this KML export to just use them in Google Maps. So the World War I database also contains World War I era boundaries for provinces of Belgium, and I can just import them now through this into Google Maps. And I could also import the events because Google Maps actually also has a format where you can, or functionality where you can draw on a timeline to see events. So I could do that here in addition to European forwarding, which isn't cooperative. No. So that's sort of a general purpose visualization tool if you know SparkUL, European 4D. And then the folks at Stanford Humanities Plus Design Lab have been working on an application called Palladio, which is an application for visualization of complex multidimensional data for sort of humanities scholars to aid them in their work visualization material. It's currently the current interface to this is that you load in CSVs. Of course, you can get CSVs from SparkUL endpoints, but I've hacked the functionality, and it will be in the next official version published here, but they didn't have time to publish that version for this talk, so I'll have to show it in my temporary URL. So there will be a load from SparkUL endpoint functionality, which for some reason isn't working. Okay. And I'm now using the 18th century European everything dataset. And there's an example query, which is pretty complex, SparkUL. this is a complex query that aggregates all letters, lifetimes, and travels into events that link together two places in Europe, sort of trying to visualize how many connections different places had in Europe in the 18th century. So you can run this query.
It's par for the course for Sidoxia, right?
Yeah, true.
The predicates look too readable for them to be Sidoxia.
No, it is actually. These are Sidoxia predicates. Beginning of the beginning, end of the end, yes. Yeah, because CDOC has sort of some support for uncertain times. So you can define time using 4 spatial points: the earliest possible start time, the latest possible start time for the interval, and the earliest possible end time, and the latest possible end time for the interval. So then you get data, and you can load it. Those are our events, and I'll have to add configuration. Palladio can sort of automatically determine some things, but it doesn't determine that these are years, because they could also be numbers. I have now sort of year information that start and end times here. Then I also had the place fields, and these are now URAs for the data, and I'll need to add an extension table here called places, and load that up with some more SparkUL. But this isn't that complex SparkUL. This just takes all the places, their names, and their latitude and longitude coordinates. Ends up with 2,500 places. We load that, and now it says that 89 of these 89 places that occur in the events were found in this secondary table. I'll also link this second place table here, and now I have sort of my data model recreated in this tool. So I have events and places, and the events are linked to places, and they have also years linked to them. After that, I can start visualizing this stuff. So I can do point to point and see all the places and how their relationships to each other are. I can size them, so I can see which were sort of the hubs of activity in the 18th century. And I can additionally just highlight sort of a subset of the time, and it'll show only connections that were active at that time.
So what are we looking at right now?
We're looking at the aggregate number of events, and events here being letters, travels, and lifetimes of people linking together two places.
Okay.
So the source location for a letter is linked to the destination location, and the birthplace to the death place, and the birthplace of the person to the sort of place where they travel, and so on.
Okay.
And this is really skewed because all our travel data is from Italy, but this is just a sort of presentation of the visualization. It doesn't show anything actually sensible.
But you could ask research questions of this, refine it to exactly what it is you want.
Yeah, much more interesting would be just to limit to actually sort of looking at travels or letters or something only, but that wouldn't demonstrate the sort of cross-dimensionality of this.
Those often centroids for those places, like that place in France, the obvious node in France. Is that the centroid of France?
Yeah.
Right. So that might be potentially confusing. Because I think there's one of those, I guess, is Paris. So
Yeah.
where it says Paris, you've got a point for Paris, and where it says France, you've got a point for the centroid.
Yeah.
So,
So if you're actually be doing work here, you'd probably want to separate, because the underlying data knows which are countries and which are cities. So when people have used this for actual research, they usually segregate by place type and sort of look at one view that aggregates by country and another that only shows the sort of city level stuff. So you don't get the confusion that's here. But that's sort of a data pre-processing step, defining what you are loading into this visualization. And you can also do just sort of graph visualizations showing which places are linked to which other places without sort of geography, because that's sometimes just useful to see it without. And if I'd have other data here, I'd see which people are linked to each other. If I hadn't aggregated them out of this, I could look at the actual events and so on. So that's a pretty nice tool. And that's the sort of final tool that I was going to show you, except so here's a really early version of another visualization that we are now developing. That is again a pure graph visualization. This is from a data set of ancient authors' citation relationships to each other, and this is now showing which other authorities have been co-cited with deities or other mythical figures. And it's sort of, all the red ones are mythical figures and all the other ones are different era authors. So the original data for this are books and their citations, but it's been sort of pivoted to show the co-citation relationships between them. And you can see that some, for example, Dionysus is only cited together with other mythical characters, but for some reason Odysseus is invoked together with a lot of real sort of people. So this is just something that'll come out eventually. That's also sort of hooked up to a SparkQL endpoint, so you can just define queries and load the stuff in and visualize it here. So there, questions, comments, and how much time?
Yeah, 5 minutes.
5 minutes, so well, not that much. All right.
So I have a question for you and Ethan and other businesses, anyone. If we think about Sparkle as the SQL or graph databases, why do we all want to make Sparkle endpoints available and would never, under any circumstances, make an SQL service directly available? And is that just that we're giving the wrong impression by saying Sparkle is like SQL and hence we should come up with a better description? Or is it a meaningful description and we shouldn't be making it work?
Well, I think actually people did make SQL endpoints available in the early days, and it was useful at the time. The problem really isn't sort of, I'd say that the problem is the other way around it, is that SparkQL endpoints aren't enough, and all of these interfaces I showed you are really bad because they force you to know SparkQL in order first to create a query that you can then visualize. So that's sort of the next thing that has to be tackled is that people shouldn't be forced to write SPARQL queries to get stuff into their fancy visualizations. And I think that's what happened with SQL, is that people developed better APIs and interfaces on top of SQL, hiding the SQL. And I'm pretty sure that we'll get sort of the same, but we'll probably keep putting the SPARQL endpoint out there so that these new layers that are on top of that can make use of those. Because SQL was sort of, when you got the better interface on top of SQL, you didn't need any more to publish that because it wasn't useful for anyone else, because that was just your data and you didn't think it was useful for anyone else. But that's not the case with a linked data triple store. You want the original data to be out there and queryable, and for someone else to be able to then build on top of that the layer that hides the SPARQL.
Spark was also a protocol, such as query language. So that's an important part of the leadership. Where the interfaces might develop to the point where they hide it, and to that extent they're often going to limit the capacity of what you can do, or what an artificial system can, artificial intelligence system can do. So we don't recommend SPARQL endpoint. You're usually doing it because you want to create limitations.
Yeah, I sort of guess that people could still open up their SQL databases, but they're worried about sort of efficiency and resource, because people can and do write bad SPARQL queries that bring endpoints down. But because sort of the landscape is a bit different and SPARQL endpoints are being developed for the open web, we are starting to see sort of good enough resource limitation schemes on the endpoint software so that you can put out sort of open SPARQL endpoint and not worry that people will crash it every minute.
But there's a semantic reasoning inherent to newer SPARQL endpoints that you don't get with exposing an SQL database, I think. And that's one of the real strengths, is that you could have some sort of thesaurus of concordances between other systems completely external with semantic reasoning with OWL or SCOS make connections that are inherent to the SPARQL processor itself, inherent to the software in the specification.
So your SPARQL endpoint is always open. Does it ever get crashed when people run a crappy query or something?
It's gone down 2 minutes in the last year. Yeah. I mean,
but you don't have data on how much it's getting hit.
I think it's probably at least 10,000 per day.
Good.
But probably in the thousands, definitely, maybe up to 10,000 per day. But I don't know how many people are actually using the SPARQL endpoint itself directly. So the queries that we have, people browsing Ochre and the other projects are conducting, whether they know it or not, are conducting SPARQL queries in the background when they go to different pages.
Right.
So they're very focused and not very complex queries that shoot into the endpoint and it responds really quickly.
Right.
But yeah, I've only had to restart Kuseki once,
Right.
and there are only 4 gigs of memory on a cloud server, so it's not like this big, like, distributed 6-server system, you know. So.
Yeah. So that's to your point, that he's like there's a web interface basically to do the queries for you, so you would never know the SPARQL, right?
Mm-hmm. But the endpoint's there. If you want to do really sophisticated queries, if you're a scholar and want to do really sophisticated stuff, the option's there to interact with it yourself.
Yeah. Alright. 332. I think the main thing that's really important to me is that you actually know that people's favorite color underwear. That's like my favorite t-shirt from being IT guys. I read your emails, so you should have a t-shirt, computer scientist t-shirt. I know your favorite color. So we have a 10-minute break.